Friends, the next step in understanding hash functions is collision resolution. Hash functions are mainly used for computing addresses, which can sometimes result in producing duplicate addresses for different key values. The hash functions by nature are computational addressing methods and result in duplicate storage locations for different key values. For example, division hash function will predict storage location of 1 for 20 as well as 30 with table size 10. This is called as collision between 20 and 30. There are three techniques to resolve collision: open addressing, chaining, and bucket addressing. First, in the open addressing method, when a key collides with another key, the collision is resolved by finding the next available table entry. Consider the following example. Three keys 5, 2 and 3 have been hashed to their home positions. Then 15 arrives, whose home position is occupied by 5. Since the next position is available, 15 is stored there. Next, 9 is stored with no problem, but 12 is stored in position 4, 2 positions from its home address. Next, 19 arrives. Position 9 is not available, and since it is the last cell of the table, the search starts from the beginning of the table, whose first slot can now host 19. The next key, 22, ends up in position 7, 5 positions from its home address. So this is how open addressing works. Another way of dealing with collisions is by means of chaining. In this technique, each position of the table is associated with a linked list whose data field stores keys or references to keys. Consider an example of a table having size 10. Suppose we want to store these numbers in the table. Let us make use of the hash function. So now 0 will be placed in 0th slot, 1 is placed at first location, and 4 will be placed in 4th position. Next is 81, and we get the hash value as 1. So this results in a collision. We therefore create a separate link at position 1 and place 81 in the linked list. In this way, the other elements are also placed, resulting in adjacency list representation. Another solution to the collision problem is bucket addressing. Consider the hash table in which the following numbers are stored. Now suppose we want to store these numbers in the table, but this results in a collision. Hence, this problem can be resolved by associating a bucket with each address. A bucket is a block of large space enough to store multiple items. Now suppose we want to store the following numbers in the table. As you can see, the bucket is already full. So, by incorporating the open addressing approach, the colliding item can be stored in the next bucket if it has an available slot, or it can be stored in some other bucket. So, this is how collisions can be resolved. You might wonder, where do we need to use these techniques? The answer is for large data sets and systems involving rapid transactions with transient data. So, today we have discussed collision resolution.